Perhaps the most recognizable element of a graphical user interface is the button. In this video, I'll explain how to code buttons using object-oriented programming in Python. I'll assume that you have an understanding of the Pygame package, as I'll use it in this video. This will be a two-part video. First, I'll show the basics of how a button works using a class named SimpleButton. Then I'll show you my more professional strength button classes, where you can build a button just using a text string or use your own graphics. All the code that I'll show here is available on my GitHub repository, so you won't need to type in anything. The material in both of these videos is included in my new book, Object-Oriented Python, which is available on Amazon, from the publisher No Starch Press, and technical booksellers everywhere. Let's get started. We'll first look at a button from the user's point of view and ensure that we understand how a user would expect a button to behave. Then we'll look at some code. With the SimpleButton class, we'll use only two graphics, an up image and a down image. I'll define a click as when the user presses the mouse button down while the cursor is over the image, then releases the mouse button while the cursor is still over the image area. This seems fairly obvious. However, if you click down while over an image and roll off and then lift up, this is not considered a click. Similarly, if you click down outside of the image, then roll over the image and lift up, that's also not considered a click. But if you click down on the image, roll off, then roll back on and lift up, that is considered a click. Here's the project folder we're going to use. We have an images folder that contains the up button and the down button, and the code will be split into two pieces. There will be some main code that drives the whole thing, and the SimpleButton code, which is a class. Let's start with the main code. The code is set up as a very standard Pygame program with some initialization up front. Then we have our main loop that runs forever, and an event loop where we check for events, and then we do all of our drawing. I hope this overall structure looks very familiar to you. At the top, we started by importing the code of our SimpleButton class, which we'll get to in a second. But here's how we'll use it. There are going to be three steps. The first thing we need to do is to create an object, a SimpleButton object, from the SimpleButton class. The second step is that every time through the event loop, we call a method in the SimpleButton object to see if the button has been clicked. And third, every time through the main loop, we call a method in the SimpleButton object to draw the button. Let's take a look at these steps in detail in the code. The first step is to create the SimpleButton object. So that code is right down here. When creating a SimpleButton object, we need to pass in 4 arguments. We pass in the window that we created up here. We pass in some XY location on the screen. And we have to pass in 2 images, or paths to 2 images. This is a path to the up image, and this is a path to the down image, both found in the images folder within our project folder. After executing that line, we now have an instance of the SimpleButton class assigned to this variable OButton. The lowercase o in front of the name is part of my personal naming convention to help me remember that this is an object. Step 2 involves event handling. So inside our big loop, we have our event loop. And to start off in the event loop, it's very typical to check for, to see if we got a quit event, to see if the user has clicked on the close button to close your program. After that, whenever we have an event, we need to call the event handler for our button. So we use this line right here. In this line we call obutton.handleEvent, and we pass in the event. So that way the button can handle any events that happen. This call results in a Boolean answer of true or false. True means that the button has been clicked on, and false for anything else. So most of the time we're going to get back a false. But if we get back a true, that means that the user has successfully completed a click on the button. And we can do whatever we want to. In this example, we're just going to print out some string to say that the user has clicked on the button. But you can do whatever you want to here, knowing that the button has been clicked on. Step 3 involves drawing the image. So down in our draw code, we make a call here. We tell the button to draw itself. And notice that there's nothing that needs to be passed in here, because when we created the button, it knew what the window was that we were trying to draw into. So the way this works is the image switching of the button is handled completely by the code inside the SimpleButton class. The action that the main program does is handled entirely by the main code. Further, the code of the class can work with any set of graphics independent of the size, the shape, the coloring, etc. Now that we've seen the calls from the main program's point of view, let's dig into the implementation of the SimpleButton class. The SimpleButton class has only 3 methods: init, handleEvent, and draw. The init and draw methods are very straightforward, but the code of the handleEvent method is a little tricky. That's because it implements a concept known as a state machine. A state machine is a software system where the code can be in one of a number of defined states, and there are a set of rules governing how the system transitions from one state to another. In the case of the SimpleButton, we'll change states depending upon what the user does. Here's a diagram of the state machine that drives the SimpleButton code. There are 3 possible states: idle, armed, and disarmed. A button starts in the idle state. In this state, we show the up image. When the user clicks down on the button, we transition to the armed state, and we show the down version of the button. In the typical case where the user clicks up while in the armed state, we transition back to the idle state, and that constitutes a click. We again show the up image. But if you click down on the image, then move the cursor off the image, we transition to the disarmed state. This state effectively remembers that you initially clicked down on the image. Now there are 2 possible paths. If you just lit up on the mouse while outside the button image, we transition back to the idle state. However, if you move the mouse back over the button image, then we transition back to the armed state and show the down image again. This state machine is fully implemented in the handleEvent method. Let's look at the code of the class. The SimpleButton class starts by defining 3 constants that we'll use to define the different states. Then we have the init method. In the definition, we get passed in a window, a location, a path to an up image, and a path to a down image. We save away the window and location in instance variables. Then we deal with the up image and the down image by calling a special function called loadImageAndConvert. We'll show you the definition of that in just a second, but the idea is to take the format of the files and turn them into a screen format. We save the resulting images in instance variables also. Lastly, we get the rectangle of the image, and we set the element 0 and 1, which are the location, into that rectangle. That way we have the rectangle of the button. And finally, we have a state variable that keeps track of our state, and we start off in the idle state. Here's the code of the loadImageAndConvert. This function reads in the file from the file system and converts it into an image format that's better suited for the screen. Remember that the main code calls handle event every time an event happens. This is where the magic happens. The job of handle event is to set the state variable to the appropriate state by implementing the state machine. Let's take a look at the code. When handle event is called, the current event is passed in. The first thing we do is we look at the current event, and if it's not a mouse motion, mouse button up, or mouse button down, then that's nothing there's nothing for us to do. So we just return false to say this was not a click. Next, we make a check to see if the place where the event happened is inside the rectangle of the button, and we set a Boolean. Next, we implement the actual state machine itself. The state machine is implemented by a simple if, elif, elif, one branch for each of the different three states. So we're going to check for the idle state, the armed state, and for the disarmed state. In the idle state, we check to see if we got a mouse button down, and if the event happened inside the rectangle of the button. If so, we change our state to the armed state. In our second case, if we're in the armed state, we check to see if we got a mouse button up and the mouse was still inside the rectangle of the button. If so, we set our state to idle and we return true. This is the case where we recognize that there was a click on the button. Otherwise, if we got a mouse motion, if the user moves the mouse outside of the rectangle of the button, we're not inside the rectangle anymore, then we change the state to the state disarmed. And in the third state, the disarmed state, if the event happened inside the rectangle of the button, then we move back into the armed state. Otherwise, if we got a mouse button up, we know we're outside of the rectangle, we set the state back to the idle state. So this one variable, self.state, implements the state machine. And if we had not returned true earlier, we return false. So if we're in the idle state or the disarmed state, we're going to return false. Lastly, there's the draw method. And the draw method is very simple. We just look at the current setting of self.state, and if we're in the armed state, then we draw the down image. If we're in the idle state or disarmed state, then we draw the up image. And that's it. So the draw method is extremely simple. So this code is highly reusable. To show what I mean, here's a main program that implements 3 different buttons. And I can click on each one individually. And even if I click down on one, roll over another one, and lift up, that's not a click. Or if I click down here and roll over here and lift up, that's not a click. But I could click down here, roll over here, roll back there, and lift up, and that is a click. And here's the main code that's driving that example. In this version, we instantiate 3 buttons, O button A, O button B, and O button C. In the event loop, we check to see if each of the buttons is clicked. We call the handle event method of each of the different buttons. And in the draw method, in the draw area, we just call the draw method of each button. The handle event call will return true or false depending upon whether a button was clicked. So from the main program's point of view, we don't need to know anything about how the buttons actually do their work. We just check to see if they return true or false. Well, I hope this explanation was clear. You can click here to see part 2, where I talk about how I do a more professional strength series of buttons.